Elon Musk, SpaceX, and yes, Mars. So, are we actually going to go to Mars? I mean, how soon could that actually happen?
Uh, Sometimes people get confused when I talk about analogs or space analogs because they're thinking like, is that analog as compared to digital, or like, what are you talking about? And what we're trying to do with analog activities or analog research is simulate different aspects of the space environment here on Earth. Immersive approach where you're going to put people in here and try to make them feel like they're on Mars.
Welcome to High Strangeness, where we ask questions and explore all that is strange and unexpected in our reality.
Welcome to High Strangeness. I'm Tony, and this is a place where we talk about all things strange and unexpected in our reality. These days, commonplace and all over the media and the news are Elon Musk, SpaceX, and yes, Mars. So, are we actually going to go to Mars? I mean, how soon could that actually happen? Well, that depends on who you ask, and it might not be that far off, actually. So, that means we're going to probably have to start preparing to get us in a place where we can do that, right? So my thought is, what if we had a way to do that? Well, we kind of do. And so I'm excited because today with us, I have somebody that's actually on location, and you'll learn about the location. His name is Ben Stanley, who is part of a leadership team for the MDRS. And MDRS stands for Mars Desert Research Station. And he's with us today to help us learn a little bit more about all of this. So I'm excited, and I just want to say, Ben, welcome to the show. Thank you so much for being here. How are you doing, my friend?
I'm doing all right. Thanks for having me.
Yeah, this is going to be very educational for me. I'm excited, and I hope other people will enjoy this as well. So, Ben, I mentioned just a minute ago, you're actually on location. So, what does that mean? Like, tell us what on location means.
Yeah, so I'm hanging out here in the director's trailer, just a stone's throw away from the Mars Desert Research Station campus. It's located in southern Utah. It's the closest town is Hanksville, and if you're familiar with any of the state parks out here, Goblin Valley is quite close by. And you may not recognize that by name, but you've seen it if you've watched the movie Galaxy Quest.
Ah,
That's where they filmed some of the stuff with the red rocks. It looks very alien, and yeah. So we're here out in the high desert, high elevation, and we found a site here to build this research station where we bring researchers from all over the world to do simulated Mars missions. And I'm staff out here, so I support those crews when they come in, train them on how to use the facility, make sure they know all the safety procedures so they don't hurt themselves or our base,
yeah.
and then just make sure that they're following the rules and that they're getting all the support that they need to do the science and various things that they're doing that they come out here for. So
That's exciting. That's really cool. So, how long and for and how often do you find yourself out at the site supporting it each year?
yeah, so currently, so I'm the assistant director of the Mars Desert Research Station, and I work under the director. His name's Sergey, and the two of us were kind of tag teaming all last year. This year we brought on one other guy. So now that there's three of us, it's roughly 2 weeks on, 4 weeks off. But of course, there's some variability, and we work with one another's schedules and who wants to be able to make certain things that they have in
Mm.
their personal lives. So, but
Well, that's cool. This way you don't go stir crazy
yeah,
out in the middle of nowhere, right?
yeah, we used to have it that we had support staff here for very, very long periods of time, and that was absolutely very challenging. So.
Yeah. Well, just looking at some of the pictures of the area and, even what's on the website, it seems like you're on Mars. So,
Yeah.
so that could get pretty hard for somebody. Yeah.
Yep. Yeah. It can be a very immersive experience. And, it's funny because the crews come out here to experience isolation and they, cut off from the rest of the world and whatever else. But funny enough, as a staff member here, I sometimes feel like I'm a little bit more isolated than they are because they
Hmm.
have themselves, right, to
Right.
interact with this crew. And yeah, I'm just here on site. Of course, I can go into town and do things that I need to and make phone calls and stuff. So, but yeah, having that face to face human interaction, having a lack of that when you're used to it, can be quite challenging.
Yeah, I bet. Well, I'm so excited to get into this today. Originally, I wanted to ask you a little bit about the history of the site and the program, and we'll get into some of that. But last week when we briefly talked, you had went further back in the history and talked about some things. And as the director of analog research, right,
Mm-hmm.
you kind of went into some of the things that kind of predated my question, really. And I'm wondering if you can go into some of that for the audience. And I thought it was great background information. Could you go
Oh,
into that?
yeah, definitely. So what we do here is analog research, and uh, sometimes people get confused when I talk about analogs or space analogs because they're thinking like, is that analog as compared to digital, or like, what are you talking about here, right?
Right.
But yeah, in this context, analog, it's just the root word is analogy, right? You're doing something that's like something else, right? And what we're trying to do with analog activities or analog research, analog studies, that sort of thing, is we're trying to simulate different aspects of the space environment here on Earth, right? Because it's quite expensive to get out into space and do research, in orbit or on the moon or on Mars, right? And so, what we're trying to do at this station and other places around the world and other places further back in history that I'll dive into here in a little bit is try to find ways that are more accessible for us to train for, prepare for, engineer for what we're going to find as we're conducting the space missions that we want to conduct, right? And yeah, in that conversation, I jumped back into kind of the early days of Mercury and Gemini and the Apollo program. If any of your listeners have watched a fair amount of space movies, they've probably seen some of these different analogs that were conducted back in the day. There's a 3-axis gyroscope thing that they sit in to simulate a spacecraft that can tumble, right?
Yeah.
Or they took the Apollo astronauts out to craters that were supposed to be similar to what they expected to find on the moon, and they had geologists there training them like, this is how we want you to go about collecting the samples. And so they got the expertise from the people that know how to do that on Earth, but then they were also working with the NASA engineers who brought out their spacesuits, because they need to know not just how to do that, what to look for, but how to do it in these big, bulky, cumbersome
Yeah.
suits, right? And so there are so many different complex challenges associated to doing basically anything in space, because it's such a harmful, hazardous environment both to get to and to operate in, right? And so we actually have a pretty long history. Well, I should say, several decades long. Long is relative depending on how you're
Hmm.
talking about it, right? But yeah, since that early time, that's when we did our first analogs to simulate what space is going to be like, what the moon is going to be like, right? For training and preparation, and we see what we're doing here at MDRS as really just a continuation of that. And rather than just planning for one specific engineering challenge or a particular aspect of training that astronauts will need to go through, we're taking a much more holistic and integrated and immersive approach where you're going to put people in here and try to make them feel like they're on Mars. And obviously, different researchers have different projects that they want to do here. Some focus on psychology, some focus on exploration, some focus on doing geology, right? There's a whole host, robotics, there's a whole bunch of different things that people do here.
Yeah.
But the whole idea is that, where some analogs can be highly targeted and specific, we tend to try to cover a lot of different bases for things that we might simulate. It's going to look like Mars. You're going to be isolated. You're going to be stuck with, the same 5 people for 2 weeks or 4 weeks or whatever, right? And learn how to get along with them. You're going to be off grid, and we just have our power systems, our water systems that we have here on site, right? And so, just trying to combine lots of those specifically with the human element. So,
Yeah. Really cool. The actual facility itself, you couple decades been there? Is that what you're saying?
Yeah, so it was founded in 2001,
Hmm.
and yeah, we had the habitat. It's a two-story building, 10 meters in diameter. The bottom floor, we've got, kind of our bathroom and the place for all of our suits for when our analog astronauts will put those on to go outside on EVA, which stands for extravehicular activity. And then on the second story, they've got their rooms where they stay in, their beds, kitchen, and dining area, and all of that. And so that's been here since 2001. And we've also slowly added to campus over time. We have a greenhouse that we have on site here that we
Nice.
call the Green Hab. We also have a repair and assembly module that we call the RAM, and we do different engineering or assembly tasks or repair tasks or whatever in there. It's actually kind of a neat building. It's a body of a Chinook helicopter that we
Oh
converted
wow.
into this like engineering bay, which is kind of neat.
Nice.
We have a geodesic dome that we constructed. We call it our science dome. There's a bunch of different scientific equipment in there for various experiments. And then we also have a couple of observatories here. We have a solar observatory and, just regular night sky viewing as well. So,
Really neat. What's the size of your typical team that comes in for this? Is it varied, or is it usually you only let a certain number in, or how does that work?
yeah, so the habitat building that we have, it supports 6 people. We have 6 beds in there. We also have a couple of portable beds if people are okay sleeping up in the loft or on the floor or whatever, that we can kind of push it up to 8. And then occasionally we do more exotic stuff where people will come out with campers or tents or whatever, and they'll say we're going to have the rest of our people camp out here, and we'll kind of take turns jumping into the habitat and going in sim there or whatever else, right? But for our facilities, standard operating procedure, typically crews are 6 or maybe 7 people.
Okay, interesting. Um, One of the things has that popped up when I was looking on your website is a Mars Society. Can
Mhm.
you tell me, what is that what is that, and what's its relationship to the MDRS?
Yeah, so the Mars Society is the organization that runs and owns the Mars Desert Research Station. It was founded by Dr. Robert Zubrin, who's one of the foremost thinkers on Mars settlement, humans to Mars missions, that type of thing. And Yeah, he's been at the head of that for, gosh, I can't remember when it was founded, but decades. And Yeah, the Mars Desert Research Station was something that he, you know, with the other volunteers and people in the society, decided they wanted to start, and we got that launched in the early 2000s, and we've been running it ever since. So and the Mars Society also operates another similar facility, that same habitat, 10-meter diameter, 2 stories. We have one up in the Arctic on Devon Island,
Oh wow.
in Canada. So, yep. And that one was it's really expensive to get out there and to do anything out there. So that one kind of went into hibernation mode for a couple years, but happy to report that we're back. We had a mission out there last summer, and we're preparing for 2 more this summer. So that's pretty exciting.
Wow, that is cool. Avoiding the winter ones, right?
Yes. Yep.
Yeah, that's interesting. So the training programs, just to further dive into that a little bit, available and utilized by civilians, private companies, or actual future astronauts, researchers. Who is participating in this? Colleges? I don't know. So,
Yeah, I would say the great majority of crews that we have out here are coming through academia and through universities.
okay.
We have a couple universities that tend to come out regularly. Typically, they put a crew out here each year. But yeah, the nice thing about working with universities is they're able to do longer term scientific work and follow up on research that they did previously. But yeah, we have all sorts. We also have occasional events that we do out here, even with local Utah educators that will bring kids out here or different things to do little studies. I know we've had crews in the past that have been a simulated mission for a family. So you have, the parents that will come out here, and typically they've got an engineering or operational background, and they'll be bringing their kids along to study what it might be like to try to actually have a family
Wow.
on a long-term Mars mission or something like that, right? But yeah, all sorts. We do have corporate sponsors for some of our crews, and then of course we just have private individuals that bring things together and organize the missions that they want to go on. So it's across the spectrum. So
That's interesting. So is there a selection process, or is there a way that a group reaches out to the organization to say, "Hey, we'd like to be a team out there"?
yeah, so if you go to the MDRS website right now, the landing page, we're in the middle of a crowdfunding campaign, so that's what the focus is on the main landing page right now. But you can navigate within that to find out more about MDRS, and there's also a section where you can click to apply to come to MDRS. And you can do that either as an entire crew if you want to build an entire mission yourself, or you can just apply as an individual and say, I have some research that I want to do. I want to come out there, but I'm not attached to a university and I don't have an
Mm.
entire crew. So this is what I want to do. This is why, and the research that I want to do out there. Uh, if you can find a crew to slot me on. And so we accept entire crews, and then we also piece together and build crews for
Oh wow,
individuals that are applying.
that's pretty cool.
Yep.
The it probably varies quite a bit, but are you seeing like what's your window of availability? So does it start in this month, end in this month, kind of a thing?
Yeah, so there's a little bit of variability, but roughly our field season matches up with the academic school year.
Okay.
We don't operate out here during the summer, and that's just because it gets too hot and we don't have sufficient air conditioning infrastructure
Yeah.
to
Yeah, I
support
bet.
that out here. But yeah, typically, if you were considering coming out here, we tend to get our cruise planned pretty well in advance. And so if you were to apply today, you might be looking at, the mission that comes from that, maybe as much as a year and a half to 2 years out from now.
Oh
So,
wow. Okay. Yeah. So hey, organizations out there, put it in early.
yep,
That's right.
yep.
Yeah. That's really cool. So okay, let's hop into a little bit of this here. Like what happens there? I'm curious. Like a typical day, I'm sure once again, depending on what's being done there, probably varies a bit. So, but let's just generically say this team is going to come out. Like, what happens prior to them getting there? Like, do they just show up individually? What does a day look like on day one for a team generically?
Yeah, so if we have a local group, usually people just kind of like come in their own vehicles or whatever else. But most people who come here are traveling from a little bit further away. And so what we typically do is we find a way to get one of our vehicles at Grand Junction, Colorado, which is the closest, decently sized airport that people can
Mm-hmm.
fly into. And they'll typically, as a crew, come in together, spend a night in a hotel there, and grab the vehicle that we've left for them, and they all drive out together. And when they get here on site, I'm here to greet them or whoever else is happening to manage the station at the time, let them settle in for a couple hours, and then we'll dive into training. And typically we have maybe 3 to 5 hours of orientation and training once they get here to be able to go through, like I said before, all the safety procedures and making sure they understand how to use the station and all of the stuff that we've got set up here. And as well as train them on the suits and the radios that they're going to use for when they go outside, and our vehicles that we have for them to use. We've got 4 of these little Polaris Rangers the kind of more utility version of the side by
Yeah.
sides, right? Um, and those are all just battery operated. They're electric vehicles, which is, much more likely what we're going to have on Mars. You don't have oxygen in the atmosphere to do internal combustion out there, right?
Yeah.
So, but yeah, so we do all of that, and once they make it through the training, then they enter simulation, and that's when they, are cut off from the outside world and not allowed to go outside without putting the suits on and going through a simulated depressurization in our airlocks and that sort of thing. So,
Wow, that's cool. So is it like, okay, everybody, we are going live. 5, 4, 3, 2, 1. Your world just changed.
yeah, typically, so we communicate via email during a communications window. We give them about 4 hours of internet access per day, usually at the end of the day. And then, in addition to that, for immediate communications, which we need to have just for safety purposes and whatever else,
Mhm.
we've got these little, just walkie talkies that we communicate with each other. And so I'll just reach out to them and say, you guys are in simulation now. Sometimes we get a little excited and creative about it with the 4, 3, 2, 1 blast off or whatever, but just kind of depends on the nature of the crew and how I'm feeling at the time. If I'm
Right.
if I'm grumpy,
Exactly.
or
Just
if they're particularly excited and animated about it. So yeah.
that's cool. And so you or one of the other couple people will be there on site
Mhm.
usually during this remote. I mean, they don't see you, right? Because you're
Right.
off. You're there,
Right.
but off site right now.
Right.
That's good. So there's some ability for you to step in if something weird happens or whatever. But
Right.
um, so typically, are you seeing a what's the word I'm going to call it? A session or a training period? Is it typically, 75% of the time it's 3 weeks or whatever? Is there anything like that? Like, is it all over the place, or do you see most of them for a certain time period when they come out there?
In terms of the length of their mission or the
Yeah,
preparation
the length
beforehand.
of their mission. Sorry.
Okay.
Yeah.
Yeah. So mission length, our standard mission length is 2 weeks long.
Okay.
And so, they come here, get settled in and finish training or whatever. So typically they don't actually enter sim until, you know, day one or day two or day two or day three rather, into their time here. And then, each day we actually refer to it as a soul, which, Martian name for day, I guess, right?
Yeah.
And so when they send in their reports each day, it's Sol 1, Sol 2, Sol 3, right? And typically it ends up being 12 days because the final day, then they leave sim, so they can do their cleaning and get ready to head out of town and take the vehicle back for the next crew to be able to pick up. We do have deviations from that. There's a group in France that sends over crews almost every year that they typically do a 4 week stay,
Hmm.
and occasionally we'll have crews that do a shorter stay, like a 1 week long, or occasionally we do have like VIP crews where we just bring people out to show them the station, and maybe it's not necessarily research oriented like most of the time, but they're here for 3 or 4 days just to help them help familiarize them with the station and what we're doing out here. So
Yeah. Yeah. Makes sense. Cool. Wow. That's pretty neat. One of the things I was thinking of is, this whole thing about going to Mars. So there is the flight preparation, there's the uh, experience of, anti gravity or whatever you would call that. Missing gravity, maybe, right? And then there's the now you're there on site in Mars and you're existing on site. It seems like what you guys are doing is we're on site, and then maybe other places are doing the neutral buoyancy thing and all that,
right,
right?
right.
Yeah.
Yeah, so gravity is one of the trickiest things to try to simulate, right? Because unless you actually leave Earth or get in orbit around Earth, there's not really a way to, consistently have real microgravity, right? but there are a couple of things that we do. You may have heard of these parabolic flights, where they will take an airplane and send it on a trajectory. Well, they'll climb up, and then they'll start arcing. So you just have your momentum carrying you up and falling back down, kind of like you're on just a ballistic trajectory, like you're a
Yeah.
ball that someone's thrown, right? And when the airplane itself is following that same trajectory that it would go if it were just like launched, then the people inside feel that weightlessness as if they're just part of the
Mm.
projectile, right? And so that's something that we do to simulate microgravity that is probably the most faithful representation of it, right? But the problem is you can only do it for 30 seconds at a time until
Yeah.
you have to like go back up, right? Um, so that's one thing. I know you mentioned the neutral buoyancy. That was something that we talked about in our last conversation. The Johnson Space Center down in Houston, Texas, they have this massive neutral buoyancy pool where they have, 1-to-1 size scale pieces of basically the entire International Space Station, and they'll have astronauts go in the pool, and they will fit them out in spacesuits that are made to be neutrally buoyant, so they won't float up to the surface, they won't sink down to the bottom of the pool, they'll just stay there, and that will allow the astronauts to work floating in water,
Yeah.
and it's going to feel similar to how it will be just floating in space, right? And that's not something that we do, right? That's
Yeah.
NASA, Johnson Space Center. We don't do any parabolic flights, but there are several different companies and organizations that do that sort of thing. So,
Yeah. Yeah. Interesting.
but yeah,
Yeah.
just wanted to confirm as well. You asked if it seems like what we're doing is you've landed there. Now, what are you going to do? That's definitely
Right.
much more what our focus is, right?
Yeah. That's pretty cool. What are the biggest physical and psychological challenges a trainee team member might face while there? We talked about it a little bit, being secluded and stuff, but
Sure.
what have you seen?
Yeah, so I think I'll start with the physical. This doesn't apply to me so much because I grew up in the southern Utah desert, and so I'm used to the climate, right? But a lot of people come here from much more humid climates, lower altitudes, right? So occasionally you get people that are reporting some sort of like discomfort or difficulty adjusting to the climate. I believe we're a little over 3,000 feet in altitude here, so we're not way up there, right? But for
Hmm.
someone who's used to sea level, it can be a little bit uncomfortable. A lot of people have nosebleeds because, a
Dryness?
combination of the different altitude as well as it's just a very, very dry climate here.
Yeah.
So there are some difficulties adjusting there. There's big temperature swings because it's the desert, right? And it can get very, very hot during the day. And when you're in these simulated spacesuits that we have, occasionally people can get exhausted, feeling stuffy. We have air blowing through them, right? But even with that, there's occasionally some heat exhaustion. We try to get ahead of it by telling them make sure you bring plenty of water and whatever else, but I think occasionally we've had some people deal with some dehydration as well, right? So that's some of the physical stuff. Psychological, yeah, it can be really challenging to just be in a new place. Occasionally we have crews that maybe people don't really know each other, they haven't met before they're doing the mission, and sometimes you just have personality conflicts, right? Personalities that just don't work very well together,
Right.
right? And I know there's been at least a couple of times too that people have uh, psych meds, whether it's you know ADHD or bipolar or anxiety and depression or any number of different things that maybe they forgot or ran out of medication, and that can be really challenging
Mm.
if they're already in a difficult, stressed, strained, you know, environment that they're not used to. And then on top of that, you take away medication that helps them function normally. That can be a pretty unfortunate cocktail sometimes. So
Yeah, I bet. Jeez. Um, has space training or simulating changed, evolved, anything like that over the last couple decades since you guys started? Like, did you start, at one point and then you said, now we know this or this, let's add this into the environment so that it's more up to date. Has things evolved like that?
Yeah, we've been so I can speak to this both from kind of just like an internal perspective, how we manage our stuff, and then as far as just the broader community of people and organizations performing these analog activities. Just as far as we're concerned, yeah, we're always looking to find new ways to add capabilities. Something recently that we've been adding all sorts of smart home infrastructure so we can track live like power usage, water usage, and temperature, humidity, and all the different areas that we have around campus. So that's been really cool. And we also have a weather station that we've added here. That's been here for much longer than that. But yeah, we're always looking for ways that we can add, additional data collection mechanisms, additional things that we can do to help simulate certain things for the crews that come out here. So yeah, we're always looking for cool stuff that way. Um, as far as the broader community, this is something that we actually feel pretty proud of because when we founded the Mars Desert Research Station, um, we actually weren't really seeing too much of any analogs out there, any analog sites that were, focused on permanent infrastructure. The neutral buoyancy lab that we talked about is a little bit different, right? Because
Mm-hmm.
this is, a simulation of the International Space Station, and they've had that going for longer than we've been operating, including back to the days when they were building the International Space Station. They actually trained them to build it in that pool as well, right?
Oh wow,
On the shuttle missions and such. But yeah, we were really the first site that I know of that was focused on, having a long-term indefinite facility on another world and trying to simulate that, right? And since then, we've seen other places pop up, both similar to what we've been doing, which, we're a nonprofit organization and, we're just trying to do grassroots thing, people that are excited about this, that want to volunteer, that want to donate money so we can try to do interesting things with that, as well as, more resourced outfits like NASA or other space agencies throughout the world. They've added additional analog sites that they use now too. So NASA has the Hera facility, which our director just finished doing. I think he was there for 30 days
mm.
inside the NASA facility. It might have been up to 45. I can't remember for sure, but they do analogs there. They've also recently completed the first mission at their Chapea analog site, which is specifically for Mars. The Hera site was more moon oriented. But yeah, we kind of feel that I can't say for certain if NASA looked at what we were doing and said we need to do that,
Right.
but I like to think that in some way, shape, or form, we really were trailblazers and pioneers in doing this sort of work in ways that, at the very least, informed the people with more money and more resources and more engineering expertise that have gone on and done things beyond what we've done and what we're doing here. So
Yeah.
yeah.
Yeah. That's pretty neat. The one thing I'm curious about is it's kind of a two-part question. So teamwork, right? Very important. Doesn't matter if it's a sport or work group or anything like that. Is there anything that you guys do to help with that? I'm curious, when a team comes in, do they set the agenda and curriculum of this period of time that they're there, or do they submit to you guys and you guys work through that with them? Like, who creates what their day looks like? That's the first question, and then also there's things like food and stuff like that. Like, is it like, oh, it's time for lunch? It's how does it work when they're there, and how involved is like you or the MDRS team with who's coming in to do this?
Right. Well, they can't order a pizza for lunch, right? But yeah, as far as like planning out the days and stuff, the first question, That's completely up to them. When they're planning their mission, they are in conversation with us about what they intend to do here. And we have an approval process to make sure that, it's going to be worth everyone's time, that they're coming here. They have specific objectives that they want to accomplish. And, we give feedback on the type of research that they want to do here. If it's going to be research involving any human subjects, we make sure that they go through the proper processes to have an IRB, which I can't remember what the first letter stands for. Internal review board, institutional review board, something like that. But just, because I'm sure you're familiar with some of the early psychological experiments, like the prison experiment and stuff like that, where all sorts of very unethical things were done, right? So,
Right.
so we have systems in place to make sure that we're following good ethical standards when humans are involved, and we just make sure that they do all of that. But other than that, it's pretty hands off. It's very, very self directed. And that's something where we differ greatly from like any sort of NASA analog facility, because they are very top down and very prescriptive, right? It's like you apply to come be an analog astronaut with us. And if you're accepted, we are going to tell you exactly what to do and what we want. And we're not even going to necessarily tell you what it's about. We're just going to collect our data, right? And it's like, it's our thing that we're doing. And you are a study participant. You're like a test
Right.
subject, right?
Right.
Whereas with us, we maintain and provide this sandbox basically for them to come in and do their own work in. And we definitely have oversight to make sure ethical rules are being followed, and, offer support and guidelines from having experience seeing other crews do similar research. But at the end of the day, we're providing a place for them to do the research they want to do, and it's it's
Yeah.
it's them making the decisions about what that is. So
Yeah, that makes sense. And it's probably appealing to them too, because they may have their own view on how they're hoping to see what happens, right?
yeah,
Yeah.
absolutely.
Um, the, let's see.
Yeah. So
Yes, sorry about that. Yeah.
so yeah, we actually have we've got a great partner in town in Hanksville. Her name's Kathy, and she runs the Rock and Riddle Rock Shop, and she has a great little section in there that she, allows us to store some of our food supplies and other equipment that we do to resupply with each new crew to make sure that they have the supplies that they need. So want to shout out her, and if anybody wants to buy rocks, definitely go check out the Rock and Riddle Rock Shop. We love Kathy; she's great, and she has all sorts of interesting things from, fossils to petrified wood to just pretty polished rocks that, jewelry all over the place, right?
Interesting. Yeah.
But anyway, so she really helps us out, and, at the beginning of each mission, I'll go in there and pick up all the supplies that they'll need for their typically 2 weeks, right?
Yeah.
And a lot of it's very like freeze dried stuff. It's the stereotypical astronaut
Mm-hmm.
food, and
Mm-hmm.
so we have most of what we get is just in big cans, like, freeze dried chicken breast or freeze dried strawberries or freeze dried potatoes or whatever else. And then they have to, come up with how they're going to cook all that and share those duties. Um, so yeah.
Yeah, that makes sense. Yeah, get them as close as they can to what it might be like.
Mhm.
Yeah. So Ben, one question as we opportunity to take a look and see what it's like there at the facility. What are some misconceptions that people might have about preparing for space? Because we were talking just earlier, and even just the food. I asked about food, and then you mentioned, the way the food would be prepared for them and how it's brought in. And I thought to myself, oh yeah, I didn't even think about that. I literally was thinking somebody's just going to make food, but that's not really what it would be like on the moon.
Yeah.
So what are some misconceptions that people might have about the training facility out there or research facility?
About our facility in particular.
Yeah.
Oh, let me think about that. Um, a lot of people think that they assume that we might be associated with NASA, right? Or that it's an astronaut training facility or things like
Hmm.
this. When, as of right now, we're at a smaller scale and scope than that. Um, but also, I don't want to sell ourselves short. We actually have had um, ESA astronauts come and attend crews out here at MDRS.
Nice.
But yeah, there isn't really any institutional involvement in terms of from NASA or ESA or some of the other major space agencies that are typically sponsoring astronauts to come out here, if that makes sense.
Mm-hmm. Yeah, that makes sense. This is not related to the research center there. Just kind of a general question. I'm curious what your thoughts are maybe on it. A lot of talk about Mars. What happened to the moon? Like, why isn't it Mars and moon preparation? It seems like we should be trying to do the moon too. Once again, I don't know. Maybe there's some other reasons for it, but it seems like that's a closer, really remote environment to also try to master too. So
yeah, it's interesting. I personally just have kind of mixed feelings about this and which one we should be focusing on. Of course, as a representative of the Mars Society, I should be talking about Mars, right? But it's a really interesting challenge, and I think that there are a lot of political realities that are going into this. And when I say political, of course, I do mean national politics and whoever's in charge of the government and making the decisions. But I also just mean internal politics, right? Of like, you have people in NASA who are working on human spaceflight, and each of them are going to have their own biases and perspectives on thinking, I think it makes more sense to go to the moon, or I think it makes more sense to go to Mars, right? And so I think there's a very human problem there of people just not agreeing and having different perspectives, priorities, biases, and there's pros and cons to both, right?
Right.
But something that I think is really interesting, and this is something that Dr. Zubrin, the founder and president of the Mars Society, talks about a lot, is if we are able to get some sort of infrastructural foothold on Mars, it's going to be a much easier place for us to like have humans long term and be able to actually utilize resources and not have such extreme costs of maintaining our ability to live there, right? It's a
Right.
very inhospitable environment, but it's far less inhospitable than the moon, right?
Okay.
So the moon is just, doesn't really have a ton to offer us, right?
Yeah.
And honestly, Mars doesn't either, but it's a lot more than what the moon does, right?
Yeah. Well, and what little I know about Mars, it seems like there's water there
Mm-hmm.
that's
Yep.
locked away, it's frozen,
Yes.
and there's a chance possibly for terraforming, right? Or
Right.
that the moon, it seems like it's just a floating rock,
Right.
right? Okay.
Yeah. I mean,
Yeah.
you could technically try to find ways to terraform either or both, but yeah,
Hmm.
any potential terraforming project on Mars would be far easier than anything you might try to do on the moon.
Yeah. Yeah.
So,
Um, One other question, and then we'll get back kind of into your lane. This question is, once again, it's about the travel. So maybe it's just not something you've thought or think about. But, I always wonder about the Van Allen radiation belt there and
right.
and the challenges that, that kind of is for even moving out of the earth here.
Right.
Is there anything does it come into your sphere at all? Like, do you guys think about that at all? Once again, you're preparing people for once they land, right? And they're
Right.
there.
Right.
So maybe it doesn't. But I'm just curious because it's just one of those things that I feel like I don't hear a lot of talk about. And I feel like it's an obstacle getting from here to somewhere else, I mean.
Sure.
So,
Yeah, so as the Mars Desert Research Station is concerned, we don't really worry about that. It's not really relevant to what we're focusing on here. As an individual, I can tell you that I got my master's degree in space systems engineering, and I took several different classes where we talked about all of the challenges associated with planning space missions, both for human space flight and just for satellites and hardware, right?
yeah.
And yeah, the Van Allen belts do present an interesting challenge, but it's actually not as serious a barrier as people sometimes think. And the reason is that it's something that you pass through briefly, right?
Right.
It would be a much larger challenge if you were doing an orbit that was continually going through the belts or hanging out in them and going with all those charged particles and ions and whatever else.
Mm-hmm.
And so you're just constantly bathed in that radiation. That would be disaster, right?
Yeah, yeah.
But if you know, things are so far apart in space, and things are typically moving at speeds that are very, very high relative to, just a stationary reference frame, that you can pass through the Van Allen radiation belts. And yeah, there's a lot of radiation, but you're only experiencing it for a very brief moment, right?
Yeah.
And so, you think about planning a trip to Mars, the radiation that they're going to experience in transit, even though the ambient radiation is far less than what you experience passing through the Van Allen belts, that's actually going to be far more serious because they're at that low level of radiation for a much longer duration, if
Oh,
that
right.
makes sense.
Yeah. I'm kind of glad I asked you that question. I didn't know he had that background
Yeah.
to talk about that. That's great. No,
Right.
that's yeah. I just wondered about that, and I don't hear a lot on it. So thank you. That's a different way to think about it. So it's passing through something or walking by something, right?
Right.
And you're not staying there hanging out with it. So versus the low level that you were talking about. Yeah.
Right. Yeah. I mean, you can think of, for example, uh, a human body is not going to survive for very long in, say, 180-degree temperatures. But if you had like an oven with a walkway through it, I could walk through that and be okay,
Right.
and get to
Right.
the other side.
Yeah.
And there's a danger if you got stuck there or whatever else, like, yeah, bad news. And it's not going to end well for you, right? But if you're just passing through very quickly, totally survivable, right?
Yeah. Yeah. That's cool. Thank you. Where do you see the future of space simulation, mission training, moon, Mars, any of that stuff, like so that it continually becomes very realistic? Do
Mhm.
you see what the future might look like there? Are you guys pretty good with what you're doing? Thinking, we're right there, so I think we're good. Any thoughts on that?
Yeah, I'd like to share where I hope the future goes.
Yeah, yeah,
And this combines, you know, I briefly mentioned my master's degree that I got there. My undergraduate degree was in economics. And for my master's thesis, I actually tried to combine the two of those, because I talk to people all the time about this sort of stuff who are just curious when they find out about my background.
right.
They're like, and some people are like the moon landing skeptics and whatever else, right? Where it's like,
Hmm.
if we went there in the 60s and early 70s, why haven't we been back? And there are lots of reasons why that's the case, but I think one of the biggest reasons is economics. And,
Yeah.
um, you know, whether you're looking at it from a government perspective of like trying to maximize public benefit or scientific benefit or whatever, right? Or military advantage or whatever it might be. Or if you're looking at it from a more private perspective of trying to make money, trying to find a sustainable business or something like that. Either of those perspectives, nobody has been able to solve the economics problem
Hmm.
of why we go to the moon or to Mars long term, right?
Yeah.
And
Yeah.
so this is something that I tried to address in my master's thesis, which is to say that I would hope that we can do a better job at bringing economics and logistics considerations into our analogs, right? And one of the gaps that I identified here is, we have people like Elon saying he wants to colonize Mars, right? Jeff Bezos has his space company, Blue Origin, and their mission statement. I might be saying it slightly wrong here, but at least paraphrasing, it's, millions of people living and working in space, right?
Hmm.
And NASA came out with the previous administration saying we're, doing the Artemis program. We're going back to the moon to stay, right? And there's been recent news about that they're changing some of the mission architecture, and it seems kind of uncertain and up in the air, right?
Yeah.
But
Yeah.
uh, but yeah, the U.S. wants to go back to the moon to stay, to put down roots, infrastructure. And China is talking about doing their International Lunar Research Station with several other of their partners, right? So So both public and private, we have all of this conversation about we are going to go to these other worlds and we're going to make homes there. We're going to settle them. We're going to build infrastructure, right?
Yeah.
And the thing that I think that's a really interesting possible future for humanity.
Hmm.
And it fascinates me to think about the possibility of that actually happening, right?
Yeah.
And
Yeah.
yet I struggle to take it seriously when we aren't really doing the preparation for that, right? Because I think in order to prepare for doing any sort of thing like that sustainably, you have to make the value case, right? This is very risky. It takes a
Right.
ton of time to develop these systems and it costs a ton of money, right? And so, what's the justification for it, right? What is the scientific return that we're getting? What is the, geopolitical, military, strategic advantage we're hoping to gain, right? What is the business case if we're trying to do like a mining operation or a
Yeah.
space hotel or something like that, right? And people are all working on these problems, right? It's not like I'm the only one that can see that this is an issue. This is something that a lot of people are working on, but as far as I can tell, I don't think that we've cracked that nut yet. And I think that's the biggest obstacle that stands in our way. And so
Yeah.
I would love to see more analog operations that are trying to find a way to focus on the costs and the risks compared to the values and the benefits
Yeah.
of doing, full integrated space missions and find a way to make that make sense. Because as soon as we can find a way to make that make sense, there's plenty of capital to go around in the world, right? And so if you can go to people who possess that capital and say, here's the story, this is why it makes sense to do this, they're going to invest in it, right? And you think about the fact that we got to the moon in the late 60s and early 70s with the technology that we had then.
Right.
Like the technical stuff, it's hard. The technical
Yeah.
stuff is very hard. I'm not going to downplay that at all. But the fact that we could do that with 1960s and 1970s technology and how far we've come from that to now, the reasons that we haven't gone back to the moon or that we haven't gone to Mars for the first time with people yet is not a technical challenge.
Yeah.
It's an economics problem in my mind, right? So,
Yeah.
yeah,
That makes a lot of sense. And I think it's interesting that your undergraduate and master's degree forced you to think not just vision, but also economics behind it too.
right.
That's pretty cool. Well, yeah, I mean, a perfect example of what you're saying is Tesla, Elon, and what he's done with cars.
Hmm.
I mean, it's ready to go much faster than the rest of it. I'm surprised that we don't have more infrastructure so that the roads can accommodate self-driving cars. If
Yep.
that doesn't happen, it doesn't matter what the car does
Hmm.
because we don't have a system in place that's allowing that to take place. I think it's crazy, but I feel like spaces like that, Elon, in my opinion, is doing some stuff to reduce cost,
Hmm.
like a lot of good stuff.
Yep.
But what's next, right?
Yeah, what you say there is actually reminding me of an interesting problem that this is more focused on satellites,
Hmm.
but a lot of companies are building out more infrastructure on orbit just with satellites and services that they can offer to other people that have satellites or different things up there, right? Which is very interesting, but they have this problem of interoperability, right? Because if I have, the way that satellites work right now, most of them have, most of the long term, like geostationary satellites that we put way up there that are very, very far away, they
Hmm.
typically have electric propulsion systems where they have a fuel, typically like a argon or a xenon or a krypton or whatever. And as soon as that fuel runs out, they can't really operate anymore. So they put them out into a graveyard orbit, so they're out of the way and they can't do anything. But you have this very, very valuable piece of hardware out there that you just can't use because it ran out of gas, you know?
Yeah.
And
Yep.
so people are like, there's an opportunity here. Let's try to find out how to refuel these so we can extend the life of these assets because they're worth multi-million dollars to the companies that run them, right? But the
Right.
problem is it's a lot easier if you have a satellite that was designed with a fuel port on it, right? That somebody
Hmm.
can come in and connect to. And it's much more challenging when you have a non-cooperative asset that you're trying to find a way to extend the life, right? And so there's a really interesting kind of tension in that whole market right now where you have startups that are saying, hey, if you put your new satellites up with this fuel port, then we're going to be able to offer you these services when you're running out of fuel in 10, 15, 20 years down the road, right? They're like, okay, I get it. Cool idea, but you haven't proven it yet. And, there's risk, and we have our mass budgets because it's very expensive to launch things, right? And mass and space and stuff that you have on the satellite bus is at a really high premium, right? So if you're telling me you want me to put this fuel port on because of a maybe that you could give me fuel in 15 years, that's a really tough sell when I'd prefer to
Yeah.
use the mass for other systems to beef up our batteries or to beef up our communications capabilities or whatever else it might be, right? So there's this very interesting chicken and egg problem. And in an ideal world, you'd be able to have somebody design everything from top down of like, let's think about the infrastructure and let's make sure everything works well together, right? But that's just not the world we live in, you know.
It isn't.
So,
No.
yeah,
Yeah, that's so true. Yeah. Well, thanks for sharing your thoughts on that. That was great.
yeah, it's a
So,
bit of a tangent. So hope that's not too far afield.
no, I loved it. In fact, I feel like our focus is this,
Yeah,
but I could talk about that for a bit if we wanted to. But,
sure.
um, anyways, this has been great. Thank you so much for sharing some of this, and I feel like I've learned a lot here, and I think people will get a better feel, in addition to the little tour there, of what's going on out there.
Yep.
Is there anything else that maybe I just failed to mention or ask that you think, hey, this is something that we should probably share? Anything like that?
Yeah, I mean, I would like to put in a little bit of a plug for a project that I'm working on right now that, as of right now, it hasn't been announced, but by the time this podcast releases, it'll be out there in the world. We
Yeah.
are working on a partnership with Purdue University to launch a journal of space analog research. And so anybody that would be interested from an academic perspective of getting involved in this, and this could involve coming out here to MDRS or going to a different analog site and collecting your own data and then publishing the research, or it can be, just looking at things that have already been done at analog sites or
Mm-hmm.
whatever and submitting papers to this journal so we can go through the peer review process and get some things published for what we're trying to do with analog research, because one of the things that we're trying to work on with this is there's so much enthusiasm for it. People love space. They want to come out and they want to have their Mars exploration experience, right? And a lot of people are trying to do really good research, but because it's such a new field, it's really disorganized in a lot of ways. And people are doing a lot of duplicative research in ways that are using different methods. So you can't even easily compare them to one another
Mm-hmm.
to, do the independent verification. That's a really important aspect of the, scientific method. And so what we're trying to do is encourage people to get more rigorous, have better academic credentials and to support what we're doing here and learn how to talk to one another so we can actually build upon research that has been done in the past rather than shouting into the void with all the different,
Yeah.
interesting projects that people are doing here, but end up not really moving the needle. We're trying to find a way to get that to move the needle more. So yeah, the journal that we're going to be publishing with is the Journal of Human Performance in Extreme Environments, and the editor in chief of that is Dr. Barrett Caldwell at Purdue. And I think again, things are still a little bit up in the air, but I think the way that we've decided to organize this is we're going to do a special section within the next issue of that journal, and I will be the guest editor of that section. And I'll be coordinating with a lot of other professionals, scientists that have a lot more know-how and expertise in the specific areas that we're going to be receiving papers on. We'll
Yeah.
do that peer review process, and we're hoping to publish some really, really good work. So if people are interested either in reading some of those papers or hopefully in submitting some of your own work, I would love to get that message out there. So
That's exciting. What's the best way for them to connect, or how can they reach out or follow this work?
Yeah, so they can, I can probably share my contact info on LinkedIn, or a email address that you can put in the show notes.
Okay.
We can do the Mars Desert Research Station website, the Mars Society website, link to this Journal of Human Performance in Extreme Environments. Yeah, all sorts of stuff. I can give you plenty of resources if you want to include that in
That'd
the
be great.
notes for people to follow up.
Yeah, that would be great. Um, Anything else that people can do to support, participate, get involved, watch everything around the MDRS?
Yeah. I mentioned earlier that we're in the middle of a fundraising campaign. We're doing crowdfunding. We've got a power system out here at MDRS that is aging and falling apart, and so we're trying to do a major upgrade to our power system. That's the main focus of this crowdfunding campaign. But if you go to the MDRS website, that's the first thing that you're going to see on the page. So if anybody wants to support what we're doing here, we would love that. The campaign includes several different tiers. I can't remember what the rewards are, or the prizes or whatever for each tier, but depending on how much you contribute, we can send you things like a model of the station, or
Hmm.
T-shirts, or various things, so that you can use to not only contribute some money to help us out, but also show your support through merch or some different things like that. So
Very cool. Yeah, very cool. Well, there you go, everybody. The MDRS. Thank you for listening, and this has been fun. I mean, we get to learn a little bit about something you probably didn't know about.
Mhm.
So I just want to say also to everybody out there, if you enjoy the variety of strange and unexpected that this podcast brings you, please subscribe, tell others about it, and hit the like button. Share your thoughts on some of this, and let's talk about it back and forth. If you'd like to train or learn or do anything with the MDRS, well, I think maybe you've received some information to see how that can happen. As we wrap up, I want everybody to just remember that there's a lot of strange and unexpected in our reality. So always keep your eyes, ears, and minds open. And until next time, stay safe.
Hey there, Strange Nation. Hang out for a few more minutes and catch this 6-minute video tour of the MDRS.
Thank you for listening to High Strangeness. This was a glance at some of the strange that exists in our reality.